Hey everyone, welcome to my channel. Today we are building this interactive environment with our hand tracked in 3D. So here you can see my hand is working and I can move it around and you can see all of this movement in 3D. So we can do a victory sign 3, 4, 5, and all of this is done in real time, and I'm able to add this to a 3D environment and run it. And all of this is working just using a single webcam, a normal webcam, which does not have any depth perception. So this means all of this is being sent to us by a normal webcam. You can use your laptop webcam or you can use any other camera that you want, and you can interact with these 3D environment. So you can see on the left hand side, it is working as well. So if we close this and if we run it again, you can see this, we can hit it, we can move it, and here in the 3D part as well, you can see how the interaction is been done. So if we increase that, you can see how it moves around in the environment, and it is truly 3D and it is quite stable to actually use. So this is a very exciting project. We will be writing the code in Python. You can see this is based on an OpenCV script. We are writing this in Python, and then we are sending our commands to Unity, which is actually getting these commands, and based on that, it is mapping it to our hand. So let's go ahead and start working. This video is sponsored by Brilliant.org. Brilliant allows you to learn interactively with fun hands-on lessons in maths, science, and computer science. It takes a step further from traditional methods of teaching, allowing you to exercise your brain. Concepts of maths and programming tend to be a bit difficult to understand because they are hard to visualize. Brilliant bridges this gap, allowing you to visualize and apply what you learn. They have over 60 courses including Python programming and artificial intelligence. The neural network course in particular is quite amazing as it visualizes digit classification in real time. Click the link below to get started for free with Brilliant's interactive lessons. The first 200 listeners will also get 20% off the annual membership. If you would like to level up your computer vision skills, do check out our premium courses that are available on our CVZone platform. Links are in the description. So without further ado, let's get started. So here we are in our PyCharm project, and the first thing we will do is to go to File, Settings, and then we are going to go to the project. By the way, the project name is 3D Hand Tracking, and we will click on the Python interpreter, and the only thing we will need is the CVZone package. So we will write here CVZone, and we are going to hit install. So this will automatically install OpenCV NumPy for us. And we will also need socket, which should be available by default. So the first thing we will do is to add our webcam. So we'll write here import cv2, and then we are going to write cap equals cv2 dot video capture, and we will capture our device number 0, and we are going to set our prop ID number 3, which is the width, as 1280, and cap dot set our prop ID number 4, which is the height, as 720. So we just want to make sure it doesn't go to 640 by 480 by default, because we want a wider area so we can move our hand more in a bigger region. So then we are simply going to go and write here while true, we are going to get the success, and the image equals cap.read, and then we are going to write cv2.imshow, and we are going to write that the image, this is the title of our image, and which image are we going to display? It will be img. And then we will write cv2.wait key, and that will give it a delay of 1 millisecond. So this is the basic code we pretty much use in every other project in which we are using a webcam. So let's go ahead and test it out, see if everything is working fine, and then we will go on to the next step. So there you go. The webcam seems to be working fine. So we are going to go ahead and move on to the next step. The next step is to actually detect your hand. So once we detect the hand, we are going to process it. We are going to create some data stream so that we can send it to our Unity project. So let's go ahead and get the hand first. So the first thing you have to do to get the hand is to import the CVZone.hand tracking module, import hand detector, and then we are going to create a detector out of this. So let's write here webcam, and we will write here hand detector. So we will write here detector equals our hand detector, and we will give it a maximum number of hands as 1, and confidence for detection confidence should be 0.2. So we want to make sure that it is actually a hand that we are detecting before sending the command. So otherwise it will be very weird when it goes to PyCharm, when it goes to Unity. Okay, so this is good. And then all we have to do is we have to write the line. So this is to get the frame from the webcam, and then we can write here that we want to get the hands. So we are simply going to write detector dot find hands, and it will give us all the hands present in this image, and it will return us with the hands alongside the image as well. So that's the main idea. And then we are going to, okay, let's just test it for now, and later on we will go to the next step. Oh yeah, so media pipe is not imported because CVZone uses media pipe for hand tracking. So we need to install that too. So we'll go to file settings, and we will go to Python interpreter in our project, and we will click add, and we will write here media pipe, and we are going to install that. So this will allow us to run our hand tracking module. Okay, so now the installation is done, so we can press run again, and hopefully this time it will work. And there you go. So here you can see my hand, we can move around, and that is pretty good. Okay, so next what we are going to do, we are going to prepare our data to send it to Unity. So what exactly are we going to send? We are going to send the landmark list. So there are a total of 21 landmarks that we need to send, and each landmark will have 3 values, the X, Y, and the Z. So these are our landmark values. Landmark values, they are basically this multiplied by, we will multiply this by 21. So that's the total number of values that we have. So what we are going to do, that accounts to 63 in total. So we are going to send all these 63 values, but we want to send it in a single list because it will be easier for us to decode when we go to our Unity script. It will make it easier for us. So how can we do this? Let's just check what actually happens by default when we ask for the landmark list. So here we are going to write if hands. So if hands are detected, then we are going to get our first hand. So we'll write here get the first hand detected, and then we are going to write here hand equals hands at 0. So this will give us the first hand. Then we are going to write get the landmark list. So here, how do you get the landmark list? You write lm list equals hand, and in the hand, this is basically a dictionary, so we can just write lm list, and it will give us the complete list of our landmarks. So we can simply print that out. So let's just write lm list here, and let's go ahead and run it. So if I bring in my hand at the back, you can see we have these landmarks. So this is landmark number 1, this is landmark number 2, 3, 4, and so on. So all of these are basically our landmarks. This is X, this is Y, this is Z. So what we need to do is we need to remove these brackets. So these brackets we want to remove, and we want all of them to be in the same list. So one single list. So how can we do that? It's very simple. We create a for loop. So we will write for landmark in our landmark list. We are going to loop through all of them. And then we are going to create a data. So before we start doing any of this, we are going to create an empty data that we are going to send at the end. So each time it will refresh. So it's good. Otherwise, it will keep adding to the previous data, which is not what we want. So don't declare it outside. Otherwise, it will keep adding. We don't want that. We want to reset it every iteration. So once we have our data empty list, what we will do is normally when we have a list, we append to the value. So whenever I want to add a value, I will write data.append. So this case, what it will do is it will do the same thing. It will make a separate bracket, it will make a separate list and append it each time. But as I mentioned, this is not what we want. We want it in a single line. So instead of append, we are going to write extend. So it will keep extending those values rather than appending them. So that is what we want. Why is this running? We need to stop that. Okay, so what we need to do, we need to add our bracket. And then we are not simply writing LM here because we have one value that we need to change. Which value are we talking about? It's the Y. So in OpenCV, this is our window. The 00 origin starts from here. So our 0 is over here and the maximum is over here. But in Unity, it's the opposite. The 0 starts from here and the maximum is here. So what we need to do is we need to reverse the Y direction so that it is correct when we send it. So what you want to do is you want to process whatever problems are in Python, you want to process them there, and then you want to send clean data to your Unity project. Now you can do that in Unity as well, but it is, again, as I mentioned, you should complete one process and send it so that you don't have to worry about that again. So this way it makes it easier to deal with all these different scripts. So what we need to do here, we will write that first of all, it should be a bracket. So we are giving it a list. You cannot give it a variable. So you have to give it a list that you want to extend. And in this list, we have to give in the first value. Then we will give in the second value. Then we will give in the third value. Now we will simply subtract our height from here. So height minus the Y value. But we don't know what the height is. We defined it here, but we didn't actually put it in a variable. So what we can do is we can write here parameters, and in the parameters we can write width and height equals, so we can write 1280 and 720, and instead of writing it manually over here, we can copy and paste. So we need the height, so we will just say height minus our LM1. So that will give us the opposite value. Okay, so this is pretty much ready. So what we can do is we can print this out. So we can print data. So now you will see the difference between the LM list and the data. That's why I have not removed it yet completely. So you will see it here. So if I bring in my hand, then you can see the first one is the LM list and the second one is the data. There you go. And now you can see we have a subtraction. So this is 720 minus 709 gives us 11. So this is what we are doing here. And now what we can do is we can send this data to Unity, and over there we can decode it. So first of all, let's go ahead and encode it. So to send our data, what we are going to use, we are going to use the UDP protocol. Now the UDP protocol is very simple to use, and the best part about it is that it does not require initial connection. You can basically run your PyCharm all the time, and whenever you run the Unity project, it will automatically connect and then it will get the data. So basically it's a broadcasting of the data, and whoever wants to grab it, they can grab. So we will tell Unity to grab that from this address. So how can we do this? We can simply write import socket, and then we are going to, after the hand detector, let's create our communication part. So in the communication, we will name it something, let's say sock, and then socket dot socket, and then we are going to write the family. So socket dot af underscore inet, and then we are going to write socket dot sock. So if you are using TCP, then you are going to write sock stream. If you are using the UDP, then you are going to use DGRM. So this is the basic idea, and then we have to give the address. So let's write here server address and port equals 127.0.0.1, and then you will give 5052. So you can basically give any number that you want over here. Just make sure it's not being used anywhere else. That's the only thing you have to take care of. So once that is done, and once our data is ready, we can simply send it by writing sock.send to, and then we are going to encode our data before we send. So we will write string.encode, and our data is not currently in a string format, so we need to convert it into string. So we will write string and data, and then we are going to write the port. So server address port. There you go. So we are sending this to this address and port number. So yeah, that's pretty much it. So we can close, we can comment these two, and then let's just run it. And hopefully if it doesn't give any error, it means it's working fine. So if we bring in our hand, nothing is giving us any error. So this means it is working. And now we can simply go ahead and open up our Unity project, and we can continue from there. So here we are in our Unity, and we are going to create a new project. This is the version number I'm using. This is LTS, long-term support, so it will have less bugs most probably than the other ones. So that's why we are using this. Now let's just call it 3D hand tracking, and we are going to create a 3D project. The spelling of tracking are wrong. Tracking. So let's create our project. Okay, so now we have our Unity project opened up, and the first thing we will do, we are going to right click and we are going to create a manager. So the manager is the object, it's an empty object on which we are going to attach our scripts. So whenever you have a script that you want to run when the game starts, you need to attach it to an object. So manager is the one that we are going to attach all our different scripts to. Okay, then we need to get our data, and to get the data, we have a very simple script, and it is UDP Recieve. And this script you can download from our website. You can just sign in and it's free to download. So you can right click here and go in Show in Explorer. So in the assets, so this is how it will look like. You will go in the assets and you are going to paste the UDP script. So now that this is done, we are going to go back. The UDP scripts allows us to receive the data. So you do not want to change anything here except for the port number. So what you want to do is you want to click and drag it on the manager. And once you click on the manager, you will see the script has been attached. And then all you need to do is you need to tell it which port number that you are using, and that's it. So we are using 5052. So this is the port number that we are going to write here. If you had a different port number, you will use the different port number. So, and here you will write start receiving right away. And if you want to see the data in the console, you can click here to see. But when you are running the game, you should not have this open. Otherwise, it will be confusing. So now we are going to go back to our Unity project. Sorry, the PyCharm project here. And we are going to run this. So when we run this, it will give us some data. And now it is going to send it there. So what we will do is we will move it over here, and I will bring this image here. Or actually, let's just run this first. So let's run that. And I will bring in my image here. And now if I put my hand up, you can see on the right hand side over here, you can see the data being received. So here you can see on the console as well. When I bring in my hand, you can see the data appears. So that is pretty good. So what I will do is I will keep that running, the PyCharm project at the back end. And whenever we want, we can run it from our Unity project. Okay, so this is good. Now we can remove this print to console. And if I run it again, it will send the data to this public variable here, data, but it will not display it on the console. So that is good. So the next step is to actually create our hand. So we are going to right click, we will create empty, and we will call it hand. And in the hand, we are going to create a 3D object, and that will be our sphere. And we will call this point, and we will enter. So this point should be 0.2 in size in terms of scale. So this is the scale, 0.2. And if you press the F button, it will take you to the point. And what we can do is we can change the color for it. Let's put it as red. So we will create a new material. So you right click, create a new material, and we will put it as green. And then over here, we are going to change the color to green. There you go. Then we will also create a red. So we'll go to material again. We will call it red. And here we are going to select the red color. So now we have the red and green color. So let's make the points red, and we'll make the lines green. So as you can see here, we have a total of 21 different points. We are starting from 0 and we are going till 20. So we have a total of 21 points. So we are going to create all of these points, 21 points, and then we will also create these lines. So these green lines we are also going to create. So let's go ahead and start. So we will need 21 of these. So we will copy and paste. And we are going to keep pasting, and we will finish at 20. And let's rename this to 0.0 so it looks good. So all of them, they are looking good. And what we can do, an extra step that we can take is we can create an empty object, and we can write here points, and we can put all the points in this what do you call empty object. There you go. So now it's much cleaner. So because we will have points and we will have lines. So these are the points. So all of them, they are at the same point right now. But later on, we are going to map the values that we are getting from our Python project, and we are going to map it to these points. And then we will need lines. So for the lines, we are also going to create a new empty object, and we are going to call it lines. And then we are going to go to effects, and then we will click on line. So this will create a line for us, but right now it's a random line. And what we can do is we can click on it, and then we can drag our green color and we can paste on it. And you can see this is basically one line and 21 points. Now we need to create all these lines as well. So we will have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So again, we will have a total of 21 lines. So let's just copy and paste. This time around, we are not going to change their names because we are going to refer them based on their starting and ending point. We are going to change them later on. So let's go ahead and start creating our script now. So what we will do is we are going to right click here and we will create a new C# script, and we are going to call it hand tracking. So we will double click to open it up. So the first thing we need to do is we need to get the data from our UDP receive. So we are receiving the data. If we click on manager, we are receiving the data in this variable, this data. So we need to tell from UDP script, get the data so that we can assign it to all the different balls. So then we are going to write here that there is a public UDP script. Why is it not showing? UDP receive, and we will call it UDP receive. So now we can link our file to this. So what do I mean by that? If I go back, you will see if I click on the manager and we drag the hand tracking, now we are putting the hand tracker on our manager. So here you will see it says UDP receive. So now we need to give it a script. We need to link it. So we will click on the manager, we will drag, and we will attach it here. Because the UDP script is attached to the manager, that's why we are dragging and attaching it here. So now our data that is coming over here will be sent to our hand tracking script. So we can access it. So that's good. But we do not know anything about our points. So we are going to write here, again, there is a public game object and it's a list of objects. And then what we will write hand points. So these are all the hand points. And if we save this and we go back, you will see there's a new variable called hand points. So, and the list is empty. So how can we add our 21 points here? So doing it one by one will take some time. So what you can do is in the inspector, you can click on lock. So this will lock, and then we can click and then shift and then click on the last one. So we select all of them and then we just drag it to our hand points. So it will automatically adjust and add all these different points. So this is good. Now we can unlock this. Now what has happened is that now in the manager, in the hand tracking script, we have the data and we have all the points. Now we need just to link them. So whatever X and Y values we are getting, X, Y, and Z, we need to send it over here. Then whatever X and Y value we are getting, we need to send it here, and then so on. So this is the basic idea. So let's open up our scripts. And here in the update, we are going to write our code. In the start, we are not going to write anything. So the first thing we need to do, we need to get our data. So string, so this is the type, and we will call it data. So where are we getting the data from? From this script. So within this script, UDP receive, there is a variable called data, right? If you remember, we need to get that. That's how simple it is. So now we have everything in the data, but there is a problem. So let's print it and see what the problem is. So we will write print data and we will save. Don't forget to save each time, otherwise it will not reflect here. So if we run it now, we are going to get the data, but let's see in the console, if I put my hand, the data is there and it is a string. So a string is just a string. So it has the bracket, it has the commas and all that. So the first thing we need to do is we need to remove these brackets, these square brackets. There is a bracket in the beginning and there is a bracket at the end. So we need to remove those. So here we are going to write data equals data dot remove, and we want to remove the 0 element starting from the 0 element, and we want to remove only one string, one character. So that is what we are writing here. And the same thing we will do here. So data equals data dot remove, and we want to remove the last what do you call character. So the last character will be data dot length -1. -1 because we are starting from 0. So whatever the length is -1, that will give you the last point. So we can save this. And now if we print the data, it will be without the square brackets in the beginning and the end. So let's run it again and see if it changes. So if we add our hand, you can see now it's just giving directly the numbers and it's not giving us any brackets. So that's perfect. So the next thing is to parse it, and we are going to actually split it into numbers. So again, it is currently a string, so we still need to create a list of strings, and then we are going to convert it into float. So the list of string will be string, and we will call it, let's say, points equal data dot split, and we are going to put in based on a comma. So I want to split the data based on comma. So wherever you find a comma, put it in a different point, call it a different point. So that is what we are going to do. Then what we can do is we can actually check if we are getting a single point or not. So we can print, let's say, points at, let's say, 0. So we will check what is the point, and then let's go back and let's run it. We put in our hand, and there you go. So here in the list, you can see the number is 445, the first number, and here we are getting 445. So that is perfect. So then what we can do is we need to send it to our hands. We need to send it to these hand points. So that is very simple. So first of all, we need to loop. So we will say for integer I equals 0 and I is less than 21, because we know it will be 21 points, then we are going to say I plus plus. So keep adding on. And here we are going to get our data and send it to our hand. So the first value we will need is float x. We are putting float because here in what do you call Unity, you can see the objects when they move, their values are very small. So if I go back here and let's say I click on hand and I move it, you can see it's in floating values. It's not integers. So there are very small floating values. So that's why we are using the variable type as float. So here we will write x equals, and then we are going to write that from our points, we need to get the I point, right? So this is the point number I. And why is it giving an error? Oh, okay. It's just, that's okay. That's fine. So it is giving us I. And what we need to do is we need to multiply it by 3, because the first x will be, for example, here, x1, then y1, then z1. And then it will be x2, y2, and z2, and then x3, y3, and then z3. So if I want to access this at iteration number 0, so that is good. But then when the iteration becomes 1, it will access this. We don't want that. We want it to access this. So it will be 1 multiplied by 3. It will give us this value. So when the iteration is 1, it will multiply it by 3 and it will give us x2. And then when the iteration is 2, it will be 2 multiplied by 3 and it will give us 6. So it will give us this value. So each time it will give us only the x value. So that's good. So we will multiply I by 3. Okay, so that's how we will get our values. And we need to convert it into float. That's why it's giving an error. So we need to write here float dot parse, And now it should not give any error. Okay, me too. Let's just comment this. And yeah, so then that is good. But if you remember, as I showed you earlier, these values, they are very small. Here you can see the Z value is 0.241, blah, blah, blah. But in PyCharm, what we are getting our values as are 200, 300, 400. So these are big values. So we need to divide them, let's say, by 100. So that's how we can get similar values so that it will be applicable in Unity. So this is for X. That is good. We will copy that and paste it for Y. Now for Y, it is pretty much the same thing, but plus 1. So here, whatever the value is 0, then plus 1 will give us 1 here. And next time it is 3, plus 1 will give us 4, and we will access this. Here it is 6, plus 1 will give us 7, and we will access this. So that's how you will write plus 1, and that's it. And then for Z, it is the same thing. So for Z, we are going to write plus 2. And that's it. So this is how simple this is. We simply get these X, Y, and Z values. And now all we have to do is we have to apply to our points. So if we are at 0, then we should apply it to 0 landmark. If we are at 1, we should apply it to 1 landmark. Then 2 and then 3 till 21. So till 20 actually, because we are starting from 0. So all our points, they are saved in hand points. We know that. So what we will do is we will write here hand points at I. This is the game object dot transform. But you will say, wait, why are you writing transform? What is transform? So if we go back and if we click on our point, you will see there is a property called transform. Within this property transform, we have our position and we have our rotation, we have our scale. So by accessing transform, we can change the position. So that's what we are going to do. So here we will write transform dot local position equals. Now we need to set in our values. You can't simply write X, Y, and Z like you do in PyCharm or Python. Here you have to write new vector 3, and then you can give in the values X, Y, and Z. So there you go. So now it should work by default. So we have pretty much written and mapped all the values. So let's save it and we will go back. Now remember, my PyCharm project is still working. So here if you see, this is still working, and when I bring in my hands, it shows. So what I will do is I will run this and hopefully it will give us there you go. So here it's giving us our hand and it looks very good. It looks really good. So let's just put it here. There you go. You can see now when I move the hand, it actually shows. Actually, let's do one thing. We'll go to PyCharm, and in PyCharm, we are going to reduce the size of the image so that we can see them side by side. So here, before actually showing the image, we will write that our image equals cv2 dot resize, and we want to resize our image, and we want to give in the size as 0, 0, and then we will write none, that there's no output, and then we will write the scale. So 0. Let's say 5 and 0.5. So we will scale it down to 50%. So let's see if that is more manageable. There you go. I think this is good. How we can manage with this. So let's put it aside. And now I will bring it here and we will run it. There you go. So now it looks much better. So you can see my hand. I can do victory, 3, 4, 5, and you can see the speed. It's real time. It's amazing how quick this is. And it looks really good. Now, one problem is that you can see when I move to the side, it's good. It's going on the right. But when I move to the left, you can see for the image, it's in the center. For the scene, it's on the center. And here it's on the left because we only have positive values. That's the problem. So here 0 is the center in Unity, and then we should have negative values and we should have positive values. So let's see what values we are getting. So if you look at which value is this? This is the X value. So look at the X value here. And based on this X value, we are going to add and subtract. So here in the center, you can see it goes X as 6, 7, something like that. And here at the end, it goes to 0. So I would say let's put 5. So we will go back here and we will write in the X value 5 minus whatever this value is. You can write 6, 7, whatever you like as well. So we will save it and we will run it again. So now hopefully it will go end to end. So if I go here, it's going on the side. If I go here, it's going on the side. There you go. So now it's a little more centered. There you go. So if you want to increase this range, what you can do is you can divide it by something lower. So here, instead of 100, you can, let's say, divide it by 70. Let's divide this by 70, divide this by 70. So let's try that again. So let's open that. There you go. So now it's a bit bigger and you can see we can move on the sides. But to be honest, I prefer the 100. So we are going to keep it 100 for now. And let's try putting 7 here. Let's see what effect does this have. Let's run that. And there you go. It goes to the right, goes to the left, kind of. So I think, yeah, that's fine. We have some, like here in the center, it is centered. And if we go here and there, that's good. So now the next step is to actually add the lines, because just the points, they look a little bit weird. So what we are going to do is we are going to add our lines. And for that, we have to create a script. So this line script will allow us to attach our different lines together. So it's very simple. It's a few lines of code we are going to write. And what we will do is we will close this and we will write here, create a new C# script. And we will write here line code. And we will open that up. Let's double click it. And there you go. So this is our line code. And what we will do is we will get the line renderer component. And the line renderer has an origin and a destination. So if we go to our lines and we click on line, you will see it has this component line renderer. So we can use this component to actually define where is the starting point and where is the ending point. So that is what we are going to do. So we will double click here and we will get the line renderer, and we will write it line renderer. We'll keep the small letters. Here it's the capital, here it's the small. So, and then we will ask for the public transform. Transform, you can say it's just the location. So we are asking for the location of the starting point. So we will call it origin. And then we are asking for the position of the destination. So these are the two things we ask for. And then in our code, we are going to link them. So first of all, we are going to get the component of this current line. So we will say that our line renderer equals get the component of this line. So we are going to attach this script to all the 21 lines. So each time it will access the script or access the line renderer of that particular line. So we will write here line renderer. And once we get that line renderer, we are going to set the width and the height, the start width and the end width. So we will write here line renderer dot start width is 0.1 f. So f is floating point, and line renderer, and we will write end width is 0.1 f as well. Now, if you want to make it like a cone, you can increase and decrease the width. So start width, you can put it like, let's say 0.5, and the end width is like 0.1. So it will be like a cone. So let's see how that looks like. Okay, that's good. And then we will write here that our line renderer, in the update, we will keep updating the value, because when the points change, the line renderer should also change. So we will write here line renderer dot set position, and we will give in the starting point. The starting point should be origin dot position. So we are getting the position from here, from this transform, and we are setting it as the starting point. And then we are going to do the same thing, but for the ending point, which will be 1. And here we will write destination dot position. And that's how simple it is. So now all we need to do is we just need to link, make sure to save it. Don't forget to save. And now here, for example, we will open up our image. And in the image, you can see the first one. Let's do the thumb. So it will be 0, 1, 1, 2, 2, 3, and 3, 4. So here we will write 0 to 1, then 1 to 2, then 2 to 3, then 3 to 4. So this is just for our reference. This writing this doesn't do anything. It's just for us to know which line are we connecting it to. So here, if we click on line, actually we didn't add it. So we need to click on all the lines, and then we need to add the line code. So we will drag it over here. We'll wait for it to go blue, and there you go. So now it says line code, and it has an origin and a destination. So for line 1, for example, it should be from 0 to 1. So we'll take point 0 and we'll put it at origin, and we'll take point 1 and we'll put it at destination. So let's run this and see if it works. So if I bring in my hand, you can see the first one is done. So it looks weird. Let's reduce the width. 0.5 is too much. Let's put 0.2. If it doesn't work out, we'll just put it straight line, you know. Let's see. Yeah, it kind of looks weird. Let's just put it at 0.1. Okay, so let's test that. Yeah, now it's better. There you go. Okay, so now we need to go step by step, and we need to change all these lines and points. So this is a time-consuming process, but we have to do it only once. So I will click on line 1 and 2. Then I will go down, and here I will click on point 1 and put it here, and point 2, and I will put it here. Then we'll do the same for 2 and 3. So 2 will go here, and then 3 will go here. And then for the fourth one, it will be 3 and 4. So let's test this first, because the thumb is done. So it should look good. Yeah, there you go. So then we have to do this for the rest of them. So 0 to 5, then 5 to 6, 6 to 7, 7 to 8. So this will take some time. So if you want to skip, you can skip this part and go ahead and do it by yourself, or you can do it with me. So this is 5 to 6, and then 6 to 7, and then 7 to 8. So we'll do one by one, and we'll go step by step so it's not confusing. So 0 to 5. So 0 to 5. And then we have 5 to 6. 5 to 6. Then we have 6 to 7. Then we have 7 to 8. 7 to 8. So let's run that. So after every finger, we should check if it's working fine. There you go. That's good. There you go. So the index is done. Now we will go ahead and do the middle finger. So 5 to 9, then 9, 10, 11, 12. So here we will write 5 to 9, 9 to 10, 10 to 11, 11 to 12. So let's put 5 to 9. So we will click on 5 to 9 and we will go down, and in the origin we will put 5 and then 9. Then we will put 9 to 10. So here we have 9 to 10. Then we have 10 to 11. 10 to 11. Then we have 11 to 12. 11 to 12. There you go. So let's test that again. And we have those correctly done as well. I think there is a little bit of a gap somewhere. Yeah, maybe this because of this. So just make sure all the points and everything does not have any additional values. So there should not be any gaps. Yeah, let's run that again and let's see. There you go. So now there's no gap. So the points are on the hand, directly on the hand. There you go. So we have done the index and the middle. Now we are going to do the ring finger. So 9, 13, and then 14, 15, 16. So the first one will be 9 to 13, then 13 to 14, 14 to 15, then 15 to 16. I think it was till 16. Yeah. So let's do that. We will go to the point system here, and the origin will be, it's 9 and 13. So we will drag 9 and then we will drag 13. Then we will go to 13, 14. So 13 and 14. Then we have 14 and 15. So 14 and 15. Then we have 15 and 16. 15 and 16. So we are almost done. Just a few more left. Let's test this one out. There you go. The last finger is remaining. So this one will be 13, 17, and then 17, 18, 19, 20. And we also have 0 to 17. So 13 to 17. So 13 to 17. Then 17 to 18. Then 18 to 19. And then 19 to 20. And the last one is 0 to 17. So these are the ones that we are going to use. So 13 to 17. Let's go ahead. We'll write 13 to 17. Then 17 to 18. Then we will have 18 to 19. And 19 to 20. And then 0 to 17. So 0 and 17. So let's go ahead and try it out. Hopefully it will be all good. There you go. So now you can see all of our fingers are there and we are able to connect and it is real time. That is amazing. So now what we can do is we can add a little bit of simulation so that it looks good. So we are going to add, let's see, what are we going to add? We are going to add a scene. Now you can find a lot of different scenes on the asset store that are free as well. But for now, we are simply going to create our own. So let's create, not an empty object. Let's create a cube and we will call it the floor. So you can actually use a quad or something like that to create it, but I'm just lazy. I'm doing it this way. So yeah, that's good. And then what we will do, we are going to create some cubes. So we are going to create empty. We will write here cubes, and or let's call it tower. And inside the tower we have cubes. So each cube we will color it red, let's say. Now I want to color, oh, it's underneath it. Let's bring it up. There you go. And then we put it here. Okay, so now this is what it is looking like. I like it actually. So now we need to add a rigid body so that we can interact with it. So here you will write rigid body. You will click on that. Let's give it a mass of 10, let's say. And now we can run this and see what happens. So here is our hand. So we are moving left and right. So we need to push it back a little bit. So this cube should be here so we can interact easily with it. So let's put this cube inside the tower, and inside this we are going to add multiple cubes. So here I will push it up, and I'm not placing it directly on top of it because we want to see some animation when it starts. It looks good. So let's do that and let's run it. So when it starts, it will give us this animation, and then we can interact with these cubes. So now we have a single tower. What we can do is we can create multiples of them. So we have another tower, right? No, not in this direction, in this direction here. And then we have two more of these on the other side. There you go. So if we run that now, and there is our hand, we can interact. As you can see, we can hit the cubes and we can do shapes, and all of this is in real time, which is amazing. So this was our project for today. I hope you have learned something new. It is quite exciting, and as you can see here, I'll bring my camera as well. So you can see here, I'm moving my hand, and that is what is interacting with this. But one thing you to note here is that you cannot go back and forth. It's just increasing the size. But if you see on the left-hand side, it's not going actually back and forth. So this is something you have to add afterwards. So try to think what methodology you can add to add back and forth. It's a very simple answer, and I believe you can do it yourself. So try to think of it and add it to this code, and it will be even more usable and applicable. So this is it for today. I hope you have learned something new. If you liked it, give it a thumbs up. If you loved it, share it with your friends, and I will see you in the next one.